Well, we have this question from Calc about points of inflection. So the question says, using calculus, find the points of inflection of the function f of x equal x to the fifth plus 5x to the fourth minus 3x. Now, first of all, we take the first derivative and then we go from there. So now we derive f prime of x is 5x to the fourth plus 20x to the third minus 3. Notice that in this question, he's asking for the points of inflection, not the critical numbers. Okay? So we don't have nothing to do with the first derivative, which we can only find them by taking the second derivative from the first derivative. Alright, so now we take the second derivative from the first derivative. Just to remind you is that our first derivative was equal to 5x to the fourth plus 20x to the third minus 3. So our second derivative will be 20x to the third plus 60x squared. Now, we found the second derivative. Now we let it equal to 0 to find the possible points of inflection. Again, the possible points of inflection. Now, we have our second derivative, which is equal to 20x to the third plus 60x squared. We let it equal to what? 0. The next step is taking 20x squared as a common factor. Okay, so we're left with x plus 3 or 20x squared multiplied by x plus 3 equal to 0. So it's either x equal 0 or x equal to negative 3. Now we check those values for x. Negative 3, 0. Now, to check the left to the negative 3, we pick some value for x. Let's say it's negative 4. Alright? And now we check for the point of inflection. So we have our second derivative, which is this one. Now, you plug in the negative 4. Okay. So this is basically is positive because negative 4 squared multiplied by positive. So this is positive, multiplied by negative 4 plus 3, which is equal to negative 1. So negative multiplied by positive is what? Negative. Then it is what? When we have negative for the second derivative test, then it's concave down. Okay, now this is the process Okay, so this is positive. And this is positive. Alright, hang on. Okay, so now we pick some value between -3 and 0. Sorry about that. So our second derivative is 20x squared multiplied by x plus 3, which is equal to this term. 20x squared is positive, and this term -2 plus 3 equals to +1 is positive also. So it is concave up because the second derivative is positive. Okay, now we check the right of 0. Okay, so let's go to the next step. Let's plug in 1. So f double prime equals to 20 multiplied by 1, which is positive, multiplied by 1 plus 3, which is 4, which is also positive. So it is concave upward. Okay, since there is no change in concavity at x equal 0, then there is no point of inflection at x equals 0 when x have the value 0. But on x equal 3, there is a change in concavity. Look here, from concave down to concave up. So to find the point of inflection, we plug in -3 into the original function. Now, f of -3 equals to -3 to the 5th plus 5 multiplied by -3 to the 4th minus 3x, which is our original function, which is here. F of x equal x to the 5th plus 5x to the 4th minus 3x. Now, returning to find the point of inflection by plugging the -3 into the original function, which we said -3 to the 5th plus 5 multiplied by -3 to the 4th minus 3x, which is -3. X here is -3 as equals to negative. Okay, now we use our calculator to find the values. Now we have this value, which is -243 plus -3 to the 4th equals to +81 minus 3 multiplied by -3. So we're left with -243 plus 405 plus 9. We use our calculator again, and we found the value of f of x, which is y, is 171, which is the y value of the point of inflection. So our point of inflection is -3, 171. Again, our point of inflection is -3, 171. So again, happy Easter. I wish that you enjoyed your Easter break, and I hope that you comprehended the question very well, and if you didn't, just review it again and again, and thank you very much.